Hello everyone, welcome to BISP Solutions. In this video, we are going to see logistic regression on HR data, and we are going to bring that data from Fusion. Let's go ahead and let's see what is logistic regression. So logistic regression is a statistical method used for binary classification where the outcome is either 1 or 0, which means yes or no. Unlike linear regression, which predicts a continuous value, logistic regression predicts the probability that a given input point belongs to a certain class. So, logistic function, sigmoid function, the logistic regression model applies the logistic functions to ensure that the output is between 0 and 1. This output can be interpreted as a probability. So this is your logistic uh, equation. It says theta z and 1 upon 1 minus 1 plus e minus z, e raised to the power minus z, where z is the linear combination of input features and their respective weights. So, uh, so mm, okay. So, so decision boundary. So, what is decision boundary? So, in logistic regression, the model predicts a probability that a given input belongs to a certain class, that is 1 for yes or 0 for no. To make a final classification decision based on this probability, a decision boundary is used. Okay. So the decision boundary is typically set at a threshold value of 0.5. This means if the predicted probability is greater than or equal to 0.5, the model classification classifies the input as 1, or if the predicted probability is less than 0.1, the model classifies the input as 0. So this threshold can be adjusted depending on the problem. For example, if false positive are more costly, the threshold might be increased to be more conservative. Okay. The second is interpretation. In logistic regression not only provides prediction but also offers insight into how different input features influence the likelihood of an outcome. Feature impact. So each feature in the logistic regression model is associated with a coefficient, which is weight. This coefficient indicates how much and in what direction the feature influence the predicted probability. A positive coefficient means that as the feature value increases, the probability of the outcome become being 1 increases. And a negative coefficient means that the feature value increases, the probability of the outcome being 1 is being 1 decreases. Okay, so let's move to our scenario. So suppose you work in HR and you want to predict whether an employee payment amount is in a specific quarter which exceeds $100,000 based on historical payroll data. So you have data from previous years, including quarterly payroll details for various employees. So the logistic regression model can help predict the likelihood that a particular employee's payment will exceed $100K based on the pattern of previous payments. This prediction can be useful for budgeting, financial planning, or identifying high earning employees. Okay, so these are the steps we are going to follow for linear regression. Oh, sorry, logistic regression. Let's remove that polynomial. So this will be a logistic regression. Okay, so these are the steps we are going to follow. First, we are going to uh, do the data pre-processing. Then we are going to select the features. Then after that, we are going to split our data set into train and test split. Then after that, we are going to train our model. We are going to find the prediction and model evaluation. So uh, let me take you to OTBI, which is our fusion, and this is the report we have created. If I come here, you can see the display name. Okay, bring it over here. So you can see the display name, payroll ID, payroll name, quarters, and the payment amount. Okay, so this is the report we have created from the OTBI, and I have already downloaded this uh, as a CSV. So you can see Amina Al Ahmed, and the first row is matching. So this is the same data. Let's move to our code. So this is our code. Okay, let's create one more. Okay, so the first thing we are going to do is we are going to import our uh, libraries. Okay, so let me import all the libraries from here. I'll explain each library. So the first library we have imported is the pandas. The second one is the NumPy. Okay, then afterward from the scikit-learn we have imported linear model, model selection, and metrics. After that, uh, for visualization, we have imported matplotlib dot pyplot and the seaborn library. Okay, so after that, let's import our uh, data set. Okay, so I'll copy and paste. And here what we are doing, I'll comment that importing data set. Okay, let me save it in the same folder where this our file is kept. So logistics, uh, logistic, okay, logistics 2. I'll give the name and let's save this. Okay, so okay, now we have splitted our data into train and test uh, train and split training set. So I'll copy this. Okay, first let's just see the output of this. Okay, so train, save, and register. Okay, so we are fetching 21929 rows and 1218 columns. Okay, now let's split the data into train and test set. Okay, so here also we are going to take the appropriate threshold on. Okay, so our threshold value is 100K. Okay, as you can see, the payment amount is greater than 100K. So this is going to be our threshold. After that, let's check the distribution of the class. Let me copy this and paste it over here. Let's run this. So here you can see the count is, now the count becomes 21537, and uh, this one is uh, 392. So greater than uh, this 100,000 is 392. Okay, so uh, now let me copy this line and we will put it into, we make some space and let's just copy this. So uh, we have splitted our data into train and testing set. Then we are going to use our linear regression algorithm, and we are going to fit our uh, X train and Y train in that. Okay, so this is our model training, which will be uh, instantiated and train the model using the training set. Okay, let's predict our model the accuracy. So this, let me copy and paste it over here. Here we are predicting our uh, accuracy of the model, what accuracy we are getting. So after that, let's calculate our probabilities. Okay, so for this we need some probabilities. So we are calculating probability. Let's compute the ROC curve and AUC. So here we are computing, we are providing the probabilities value and the y-test into our ROC curve. Okay, so now this is for visualization. Let me copy the code and paste it over here. Okay, so this is simply the figure size. What figure size we want is 8:6. The color we have selected, and these all are coming from the matplotlib.py library. Okay, so okay, this is X label false positive rate. Okay, so this is the label we are providing. The Y label is true positive rate, and then the title is receiving operating characteristic ROC curve. At the last, we are simply showing our uh, graph. So let me save this. I'll remove this and let's just run this code. Okay, so this is our ROC curve, and the accuracy of the model you can see is 98%. So our model is quite accurate. Okay, so thank you for watching the session. We will meet in the next session. Thank you.